Alright, this is going to be a very quick video in which we describe ways in which we measure quantities in physics. Okay? And the way that we can measure quantities is either as a scalar or a vector. Okay? So the title of this is going to be Vectors versus Scalars. Okay? So what is the difference? The scalar is a physical quantity that can be described completely by a single number with a unit. So a physical quantity that can be described completely, which is an important word, by a number and a unit. A vector, however, is something that has both a magnitude, which means size or amount, and a direction. So that is important. That is the key word there, a direction. So let's just look at some examples, and I'll give you a chance to sort of think about these and guess. Number one would be 37 degrees Celsius. So just think about that, and remember that direction is the key word. So number one is a temperature measurement. Does temperature have direction? Well, the answer is no. So this would be a scalar quantity. It can be completely described using a number and a unit. Number two, 10 seconds. Again, this is a measurement of time. The question is, does time have a direction? Well, you might think that time can move forward, so it has sort of a direction, but it doesn't have a direction in physical space. So time is a scalar as well. Alright? How about if I said 35 miles per hour north? Well, that should be pretty obvious, right? I said north. North is a direction in space. So 35 miles per hour north would be a vector. Right? How about gravity? Again, if we think about this and we address the direction question, does gravity have a direction? Well, the answer is yes. Gravity goes down. It always goes down or towards the center of an object that has some mass. So gravity is a vector. Number 5. About 6 kilograms. Well, kilograms does not have a direction. It's a mass. It's different than if we were to say weight of something, because weight does have a direction because it's a result of gravity. But a mass does not have a direction, so this would be a scalar. Last, let's say friction. So if we think, does friction have a direction? And this might not be as intuitive to answer, so let's just look at an example. If I had a box on a table and I were to push it in that direction, think about which direction friction will be acting. It actually acts in this direction, right? Because it's slowing the box down. So friction does have a direction, so it is a vector. So I hope that you now have a little bit more clear understanding about the difference between a vector and a scalar, and we'll get to applying these to our first unit on motion in the next lecture.